We start up typically 6:30, maybe 7 o'clock at night is when our observations start.
We're all set up. We're systematically going through this grid of telescope positions, 12 pointings, a 3x4 grid, to just cover the whole area that we need to cover with the camera. And we spend about 15 minutes looking at each field, and then we move to the next one and just go systematically through them like that. And then when we're done, we do it again, because we want to look at each field at least twice. And we've had time also at the Magellan telescopes down in Chile. Hey Dave, how was the seeing tonight?
Points, as good as 0.55, I guess. But
That's modest.
most of it was 0.65 to 0.855.
Okay. There at the Magellan telescope, it's a 6.5 meter telescope, a little bit smaller than our 8 meter telescope, and they're using a camera that has a little bit smaller field of view. So they've been focusing on the center of the field where we're most likely to find an object, while we have been looking a little bit wider, but they were using longer exposures so they can go a little bit deeper in the center of their field and maybe find some fainter objects. So we're a little bit complementary that way. It's kind of unusual to have two of the world's big telescopes looking at the same field doing the same thing at the same time, but it does happen from time to time if there's something really critical where you really need that collaboration between the two telescopes. Here it's just so important. We're not going to see any Kuiper belts with New Horizons if we don't find them with our telescopes right now. Each time we go to the telescope, we take hundreds of images. We try and find things that move, then we try and find them again in those observations taken at another time. By connecting those dots together, we can find the orbit of the objects and then find the ones that are on the trajectories that we think we can reach with our spacecraft. We're taking 7 individual images of 90 seconds each. There are all kinds of bright stars in here. We're looking in the Milky Way, and if those stars are exposed for too long, they get overexposed and they just produce trails all over the image, and it gets really ugly. And we wouldn't be able to see our Kuiper belt objects in all that mess. We solve this problem by taking a series of images over a period of time. The stars stay put, the Kuiper belt objects are moving slowly against our star background. So that's the trick we're going to use to sift through this enormous amount of data and get rid of those pesky stars and find the Kuiper belt objects that we need. And if we're really lucky, we'll have a choice of 2 or 3, and we can say, oh, this one looks really juicy, let's go after that one. Or we may just have to settle for the one we can reach. Or we may find none at all. Of course, we don't know what these things are going to look like. No one's ever seen one up close. We know they have quite a variety of surfaces. There are objects out there with different colors and compositions of their surfaces that are quite mysterious. We know quite a lot of them have moons. And so it'd be really cool if we can find one that has a moon and we get two objects for the price of one, and also it will tell us something about how those satellites form. So many mysteries that we want to understand when we get out there.
So we got a lot of really good data that came out last night from the New Horizons mission. You really couldn't almost ask for basically a better night on Mauna Kea.
We're observing 12 different fields. We had 6 of them that were highest priority, where we were most likely to find a Kuiper belt object that New Horizons can reach. And we just nailed those. We covered them multiple times with enough time between those visits that we would be able to see things moving between them. We don't know yet what we got. It's going to take a long time to find out, but the data looks really good. And so we're going to go home satisfied. We've gone an awful long way to get to Pluto, but once we pass Pluto, we're going to have a beautifully equipped, very healthy spacecraft that's just going to be itching to do something else good for us. We want to explore, see what's out there. I mean, whenever you go somewhere else in the solar system that you've never been before, with equipment you've never had before out there, you always see something amazing. So we want to go somewhere else and see something else amazing.